completing the square. So in words, to complete the square for the expression x squared plus bx, we're going to add the square of half the coefficient of the terms bx. And so in algebra, that means x squared plus bx plus parentheses b over 2 squared is equal to x plus b over 2 squared. So as hard as you think that sounds, it's really not that hard. So basically, you've been doing that and you haven't even realized that. And so x plus 4 squared, basically that means x plus 4 times x plus 4. And if I was to go in and I go in and FOIL that out, I'm going to get x squared plus 8x plus 16. So these two are equivalent. And so basically what this means is that if I have this trinomial and I want to go complete the square, basically what I'm going to do is that this is my bx right here and this is my c. I'm going to go in and I'm going to take half of this b right here. And so half of 8, which is 4, and that's where that 4 comes from. That's all that is. And if I want to find my c, so half of 8, which is 4, and then I square it, I'm going to get 16. So that's all this is. So if I gave you x squared plus 6x plus 9, and I wanted to write this and complete the square, basically what I'm going to do is I'm going to take half of 6, and so what's half of 6? And that's going to be a plus 3. And so that's how I will do that. And if I wanted to find this other value over here, that would be 3 squared, which is 9. And so that's how I find my c value. So basically we're going to take half of that b is 3, and that's how I come up with this number right here. So to find the value of c that makes the expression a perfect square trinomial, so we're looking at perfect square trinomials, we're going to write the expression as the square, and that should be a square of a binomial. Okay. So we're going to look for two things. We're going to look for the square binomial, and we're looking for the c. So I'm going to write it in two different forms. The thing we have to remember is that c is always going to be positive. And that's because I always square it. So if I have x squared plus 8x and I'm looking for my value of c, first thing I'm going to do is I'm going to divide my b by 2. So 8 divided by 2 is going to give me 4. So when I write that as a square binomial, that's going to be x plus 4. If I want to find my c value, I'm going to take that 4 and I'm going to square it, and my c value becomes 16. So completed, this would be x squared plus 8x plus 16. So if I go multiply that out, that's what this will equal. So this is my b value right here. So what we're going to do, we're going to divide this by 2. And so to write this as the square binomial, we're going to take a negative 12 divided by 2. This becomes a negative 6. And if I want to find my v value, or my c value, I'm going to take a negative 6 times a negative 6, and that is going to give me a positive 6. And that's why I said that c is always positive. And so this is equal to x squared minus 12x plus 36. So this is our perfect square trinomial, and this is a square binomial right here. My square binomial, and this becomes a perfect square trinomial. X squared plus 3x plus c, divide that by 2, so my square binomial becomes x plus 3 halves. And if I want to find my c value, I'm going to take that 3 halves, and then we'll square it, and that becomes 9/4. Now make sure that you always reduce. And so if this was 6 over 4, you would want to reduce that. And so our c is equal to 9/4. So this would become, as a perfect square trinomial, this would be x squared plus 3x plus 9/4. Okay. All right. So Now we're going to go ahead and we're going to move on and we're going to look at the vertex form. So the vertex form of a quadratic is f of x equals a parentheses x minus h squared plus k. So this is the vertex form. Super important form right here. So you might want to get an index card and write that down. The line x equals h is the axis of symmetry. Super important. So x is equal to h. So this point right here is going to be your axis of symmetry right there. The vertex of the parabola is h is equal to k. The other day we called that c. So c and k are going to be interchangeable. The maximum or the minimum value of the function is k. This tells you right here that's your max or your min, depending on whether it opens up or if it opens down. So looking over here, so f of x equals x minus 2 plus 1. So this tells you your a, this tells you your h is 2 because this is a negative, so it's the opposite of that. And your k, which is this value, which is a 1. And so this is going to be your vertex. Your vertex is 2, 1. And so we talked about this the other day, is that because we have to write this in vertex form, this is going to be x minus a plus 2. And that is the reason why this is a positive. And so this is a positive 2, and this is a 1. So opposites lie, the easiest way to remember it. And so your vertex is 2, 1. That's how that works. The axis of symmetry is going to go through this B, which is right here, through this point right here. And so it's through your X. And so that's where that 2 comes from. Interpreting the vertex form. So y equals 6 parentheses x minus 5 squared minus 1. What are the vertex? And so we're looking for the h and the k, the axis of symmetry. And so we know that x is equal to h. The maximum, which we know maximum or minimum, we know that that's going to be our k value, and the domain and the range. So the things that we know from this right here. We know that the 6, this is our a value, this is our h, and this is our k. So I'll write over here that this is going to be a vertical stretch. So it has a vertical stretch with a scale factor of 6, so we know that that's going to be very narrow. We know that it's opening up. This tells me I'm getting my horizontal movement, and so we moved horizontally 5 units, and that went to the right. And then this minus 1 tells me that we've translated down. Translated only has 1. So we translated vertically. We want to make sure we use all those words vertically and horizontally. Down 1. Okay. So our a value is this value right here, which is 6. Our h is 5, and our k is going to be negative 1. So we know that this is opening up, and so this is going to be a minimum. So that is a min because we know it's opening up. Our vertex is going to be our h and our k. Our vertex is going to be 5, negative 1. And our domain and range. So our domain and range. So we can do a brief sketch over here. So 1, 2, 3, 4, 5. We know this is going to open up this direction. We know that our axis of symmetry is going through this point, so this is x is equal to 5. Oops, x equals, that should be down here. That should be down there. This is what my vertex looks like. Okay. So my domain is going to be all real. And then My range is going to be all the points that are greater than that, and so y is greater than or equal to -1. Our vertex axis of symmetry we know is x is equal to 5 is our axis of symmetry. And we can also go find our y-intercept very, very easily if I wanted to go in and graph that. And so just by definition, we know that x equals 0. And so we'll plug in a 0 in our equation. And so we'll have y is equal to 6 parentheses 0 minus 5 squared minus 1. And so we'll have y is equal to 6 times -5 squared minus 1. And so hopefully you're not taking 6, multiplying by -5 and then squaring. So you should have y is equal to 6 times 25 minus 1, which is going to be 150 minus 1, which is 149. So my y-intercept's all the way up here, which is 0, 149. Okay, so those are all the different things that we can go find from this graph. We can find our domain, which is all real, our y-intercept, which we already know that this is going to be a min, so this is y is greater than or equal to -1. We know our axis of symmetry. We're able to find our vertex. We can tell that this is a vertical stretch, so these are going to be probably fairly close together. We know that this opens up, so there's a lot of different information you can get from this. All right, so looking at this next one, it says graph y equals negative parentheses x that this is going to be a reflection across the x-axis because this negative is outside the parentheses. That is going to go horizontally. It's going to go left 2. And then this +3 is where we're going to get our vertical movement. And so vertically up 3 units. Okay. We also are going to identify our A, our H, and our K. And our A, there is going to be a -1. Our H is equal to a -2, and our K is 3. So that means that our vertex is going to be a -2, 3. Since this is going to open down, we also know that we have a max value. So we know that this is a max. And the max value is going to be at this 3. Y equals 3. We know the axis of symmetry. And so our axis of symmetry is going to be x is equal to a -2, and that came from that value right there. And so we can go find our y-intercept, and so we'll go in and plug in a 0 here, and that's when our x is equal to 0. So we'll have y is equal to -0 plus 2 squared plus 3. So y is equal to -2 squared plus 3. And so y is equal to a -4 plus 3. And so my y-intercept is -1, which is the ordered pair 0, -1. So those are the things that I already know. So I can just go in and maybe get a little tentative sketch right here, because you already know I'm not the best artist in the world. Okay, so I know my vertex is at -2, 3. So 1, 2, 1, 2, 3. So here's my vertex. I know that my axis of symmetry, I know that 0, -1, this is where it's crossing. And so I can go ahead and tentatively draw it like this. Okay, so it should look something like that. And you can have your axis of symmetry going through it. All right, what is the graph f of x equals negative 3 parentheses x minus 1 squared plus 4? What is a, k, h? What is the transformation of the new? All right, so a equals negative 3, h equals 1, k equals 4. The vertex is 1, 4. It's a reflection across the x-axis horizontally to the right 1, vertically up 4. Your domain is all real, and your radius is y. All right. If the vertex is 3, 6 and the point is on the path 7, 5, write this in vertex form. So we have to find A when it tells us to write it in vertex form. So we have to find A. So this is going to be our vertex, which is our H and our K. And basically a point on the path, this is just your X and your Y. So our formula, y is equal to a parentheses x minus h squared plus k. So if we can find every single value except for a, we can plug those in. And so if this is our x and our y, we can plug in a y. We know the x, we know the h, and we know the k, so we have everything we need except for a. So we can go in and we can plug in. We know that over here our y is 5 because this is the 5 value right here. I'm looking for the a value. My x comes from right here, which is 7. My h is going to be the 3 value. And then my k value is 6. So I know every value but a. So then 5 is equal to a times 7 minus 3, which is 4 squared plus 6. I have to follow PEMDAS. And so now I'm going to go in and I have 5 is equal to 16a plus 6. Get the a by itself, so I'll subtract 6. I'll move this over here. So I have a negative 1 is equal to 16a. Divide by 16. And so then a is equal to negative 1 all over 16. So the things I know now that I found the a, I know that this is going to be a reflection. I know that this is opening upside down. I know that this is going to be a vertical compression because this number is small. Those are the things I know. I know that this is also, since it's going to be upside down, this is going to be a max. So now I'm going to rewrite my formula, which y is equal to a parentheses x minus h squared plus k. And I'm going to not fill in the values for my y and the x, and I'll plug in everything else. So I have y is equal to negative 1 all over 16, parentheses x minus 3 squared plus 6. And so this right here is written in vertex form. And so this tells you that you have a reflection across the x-axis. You have a vertical compression. This is moved 3 units to the right and 6 units vertically up. So those are the things that you know just by writing your equation in vertex form. So vertex form is very, very important to us because it gives us a whole lot of information. It'll tell you your axis of symmetry. We can go find our y-intercept from here. So a lot of information. All right, so we're going to start with 2 parentheses x plus 7 squared minus 2. It says, rewrite the function from vertex form. So this is in vertex form to standard form. So standard form is ax squared plus bx plus c. And so the things that we know that this is in vertex form, so I already know that what my vertex is. So my vertex is going to be negative 7, negative 2. I already know that this should be facing up. I know this is going to be a vertical stretch, that this should be shifted over 7 units to the left, and it should be down 2 units vertically when I get done. These should be equivalent, and so if I was to go graph this equation and my new equation, they should be right on top of each other. And so I have to follow PEMDAS. And so I have to take care of my parentheses first. So take care of the exponents. So take care of your exponents. So I have y is equal to 2 parentheses x plus 7 squared minus 2. I got to take care of this part right here, which means I have to go factor that. And so that becomes y is equal to 2 times x plus 7 times x plus 7 minus 2. So we're going to go FOIL that. And so we have y is equal to x squared plus 7x plus 7x plus 49. So that becomes x squared plus 14x plus 49. And then bring down your minus 2. If you're not sure what that means, hopefully you know that by now. That means x plus 7 squared. First, outer, inner, and last. I'll let you go work that out. I'm not going to do that. We've been doing it for a while. And then now, before I go in and do the minus 2, don't forget you have to multiply by 2. So don't forget to bring that 2 down. So then I have y is equal to 2x squared plus 28x, and then 2 times 49 is a positive 98 minus 2. Do not forget, oops, where'd my paper go? Do not forget to multiply by this 2 right here. Make sure that you're carrying it all down. So then you want to go in, combine your like terms, and y is equal to 2x squared plus 28x plus 96. The next part, it says use this equation to evaluate f of negative 1. So there's 2 different ways. You can go in and put that in your graph, and you can go graph that. Use your table by using Control T, which we've done that before, or you can just go in and do f of negative 1 is equal to 2 times negative 1 squared plus 28 times negative 1 plus 96. And hopefully we're getting a lot better at evaluating. I can't take 2 times negative 1. I have to take care of my exponents because I have to follow PEMDAS first. And so this is going to be a negative times a negative, which is a positive. So that's going to give me 2. And then I'm going to get a negative 28 plus 96. That'll give me a negative 26 plus 96. And so then f of negative 1 is going to equal 70. And then you'll square it, so you're going to have x plus 25, and then square it, and then to find c, you're going to take c and square it. And so 25 times 25 up to the 625, and so then you'll rewrite this as x squared plus 50x plus 625 is what you'll do on that. Looking at number 9, it says rewrite these functions from Vertex to standard form. Then use either form to calculate f of 1 and f of negative 1. So we're going to go in, and you have to go in and take care of your parentheses first. And so you have to take care of x minus 4 squared first. And so remember, x minus 4 times x minus 4. And so that becomes x squared minus 8x plus 16 minus 3. So y is equal to, and then you'll have x squared minus 8x, and then 16 minus 3 is going to be a plus 13. And then from there, you'll go in and evaluate it.